Hello, and welcome to this Valentine's Day edition, February 14th, 2018, of the SIG Cluster Lifecycle Cluster API Breakout Working Group. Today we are lucky enough to have Eric Toon joining us after our conversation last week about CRDs versus API aggregation. We looped Eric in to come and sort of continue that conversation and hopefully get to a good conclusion. So for both sort of short and long-term answers for the future of the project. So I don't know, Eric, if you had a chance to read through any of the notes from last week, or if you're going mostly on what we spoke about offline. And you're muted. We kind of flipped through your presentation last week. I don't know if you wanted to walk through the slides at all again, or if we just wanted to talk about it.
Yeah, I updated them slightly to reflect the latest thinking, but they're pretty much the same. Did not have a chance to read your notes. Maybe the easiest thing to do would be to do Q&A, or if you think there's enough people that haven't read them, I can flip through them quickly.
Why don't we flip through the slides quickly, and that'll give us a chance to ask questions about them as we go. Because I think I had a couple of questions. I'm assuming other people might also.
Okay. Tell me if you see my screen share.
Yes.
Okay. So my pitch is use CRDs whenever possible. CRDs has way more users than aggregated. Here's a bunch of people that are using them and seem to like them. I've talked to most of these people. Istio I work with very closely and talk to them like at least weekly on their needs around CRDs, and I am highly motivated to keep them happy as they are close peers. And I think also other people that are in the Kubernetes space outside of Google are also excited about Istio and share a motivation to support that use case as something that easily installs on your Kubernetes cluster. And there's also a lot of people building operators, and then there's a bunch of other peripheral things. So a lot of people are succeeding with CRDs. So there's momentum I just talked about. There's a lot less code that you need to, if you just want to do basic validation and define a schema, then you have to write no code to use CRDs except for your controller, which you're going to write either way. If you want to do fancy things with validation, then you end up writing some code for that, and it's similar to an aggregated API server, but you end up like the amount of code that you've forked and have to rebase is more than 10 times smaller. And you don't ever have to run your own etcd. Assuming you have a relatively small number of objects, small meaning the number of like clusters or cluster objects is much smaller than the number of pods, then you're going to be in the noise in terms of the API server, the etcd's load from your resource, so you shouldn't worry about that. And there's one less moving part in your cluster in that case. So they can do a lot currently. They can do quite a bit of validation. Some examples are like min and max values for fields, pattern matches for strings, uniqueness requirements, one of. If you follow that link to OpenAPI v3, you'll see there's a ton of things that you can do without writing any code, just a schema. You can, as of 1.9, you can do any kind of validation you want using a validating webhook. People have used those with good success. And you can do any kind of crazy defaulting you want using a mutating webhook. So that's also been used with success by the Istio project. So the biggest gap we know people have asked for is multi-version support. We're trying to squeak something out for 1.10 that will at least allow you to like promote from like a V1 Alpha 1 to V1 Beta 1 or to V1 whatever, with there's no changes in your schema, just communicating like, yeah, this is more production ready. And then probably not in 1.10, but by 1.11, we're going to have at least the ability for you to like rename fields as you go from versions to versions. And then we definitely eventually are going to have an escape hatch where you can do arbitrary transformations. It's probably worth having a conversation if you guys want about how versioning and storage sharing works in Kubernetes, if that's not clear to everyone. I'm going to talk fast, but just butt in if you have questions. So And then the whole CRD thing, we have a goal by sometime this year to like bring the whole thing to V1. So you shouldn't be worried it's going to go away. One thing that's going to happen is we're going to revamp like how strategic merge patch and apply works this year. And if you're building an aggregated API server, you're going to have to rebase your code to pick that up. If you're using a CRD, the expectation is it'll just magically happen when you upgrade the API server that it's installed in. So again, less rebase pain with CRDs. The times I would say to use API aggregation is if you're a facade in front of some other kind of storage or API, or you need to like use a fancy sub-resource like connect or stream. I think you guys said you might have had a case like that, which is where you wanted to maybe SSH to a machine or something?
No. Why don't you finish your presentation, and then I'll have you go back, and I'll start taking questions.
That's the whole presentation?
Okay, excellent.
I'm happy to go back.
All right. So if we go back to slide 3, we're talking about benefits and try to figure out how those apply to us in particular. So the forking and rebasing code, Fang found that there's an API server builder, which allows you to auto-generate most of those 6,000 lines of code, which I think significantly decreases the pain of forking and maintaining your own code. Probably doesn't get rid of the rebasing pain entirely. And some people last week mentioned that rebasing can be rather difficult with the API server. But I think that sort of reduces the impact of how painful it is to maintain that forked code base.
I agree with that. The person who wrote that, one of the people who wrote API Server Builder is now working on an improved version that can spit out either a CRD or an API server based on your preference.
Cool. Yeah, that's good to know. So for running a separate etcd, you talked about how if the number of clusters or machines is small compared to pods, it's sort of in the noise in terms of storage. But one thing we've talked about is for sort of reliability and availability, we actually would prefer to have it in a separate storage environment so that being able to figure out the desired state of your cluster is possible if your cluster control plane itself is down. And in particular, if you're modeling your master machines as machines in the machine API and you screw them up, it would be nice to be able to recover from that broken state. And so
you're concerned that you want to do like software fault isolation by like partitioning a simpler API from a more complex API that's more likely to break.
Yes, and I think that the main Kubernetes API server is more likely to break, especially as everybody else starts using CRDs and increases the chances that it becomes fragile in unpredictable ways. And having the machines and cluster API in a separate etcd that's less likely to go into an loop if we're not doing proper garbage collection of leaking job objects or something seems like a good reliability story for us.
That does make sense. I think that is a good reason to want to have separate storage. I'll point out that another thing you can do, which I should have talked about in these slides, is you can run the latest release of Kubernetes API server, turn off the other APIs that you don't need, basically have no nodes, and install your resources as CRD inside that API server. So again, you're actually not owning any code.
Yeah, but I think he's just pointing out that not running a separate etcd is not necessarily a benefit to us.
That is, I agree with that.
Okay. And the last one, I think lower net memory requirements is tightly coupled to that sort of same deployment scenario where that's not necessarily a benefit to us because regardless of whether it's a forked API server or our own with all of the default APIs turned off, it's sort of the same footprint in terms of resource usage.
Yep. If you guys feel strongly about the fault isolation, then I would say continue on your current path of using aggregation. And at some point, if rebasing becomes difficult, I'd be happy to have a conversation about how to switch to using the released API server binary. But that would mean you would want to be disciplined about not doing non-standard things in your API server code.
Right. And I think that's sort of the conclusion we came to last week was that short-term tactically for a number of reasons, including the fact that like a lot of the stuff that's on the CRD roadmap isn't there today, and we want to have stuff working today. It makes sense to continue with an aggregate API server in the short term. I think what we're really looking at is where is the sort of long-term convergence, and do we want to always have a separate aggregated API server, or do we want to sort of converge back with the desire to have people using CRDs, even if we have a deployment model where we run our own API server binary, if it's not a forked API server, if it's just an API server with CRDs installed.
But do you see your APIs being one-to-one with a Kubernetes cluster, or is it more like it's global in the sense that it might manage lots of clusters?
So it's the latter.
I want clusters in US and Europe. Would I run one of your guys' API servers for the whole world, or would I run one for each region?
One for each right now.
Well, it's sort of both, right? So we talked about having, there's a discussion on a GitHub issue, and I think Chris was driving this about, or Chris Rousey, about whether machines and clusters should be namespaced. And what we decided on was that we would allow them to be namespaced, and that sort of by convention, although not enforced, if they're in the default namespace, that means they're the local cluster resources. And if they're in other namespaces, they could represent remote clusters. So that would allow people to have a deployment scenario where you had sort of a single API endpoint that was managing multiple clusters if you wanted to use the API.
So if you wanted to have a completely separate clusters API endpoint, then you just wouldn't use the default namespace, and you would just have a namespace for every managed cluster.
Right. I think the pattern we think will be the most common, especially in clusters that people are building and running themselves, is that it'll be a one-to-one mapping, like Frank was saying, where it sort of lives in your cluster in the sense that you could run kubectl get nodes, kubectl get machines, hit the same aggregated API point, it'll go to two different API servers and give you back the right resources. Like that's the most common case, but we wanted to leave the door open for the case where you'd be running controllers to manage things remotely. Because it sounded like there were a number of people in the working group where that would be very useful to them down the road.
Okay, so I for both your globalness and your fault isolation needs, it's clear that you want to run what I call a standalone API server, one that's not associated with a heavily used Kubernetes cluster. I think you still have your controller manager, you imagine you'll just run on the same VM as the API server, or perhaps you'll like build that into the same process?
Yeah, I think right now it's a separate binary. I think by default it just runs in the same place, but it's flexible, right? It's a controller, it can kind of run anywhere.
Okay, so your requirements make sense. I'll update my slides to reflect that what you're doing is another time it makes sense to not maybe use CRDs, and I appreciate you guys giving me feedback on that.
So the other thing I wanted to follow up with is it sounds like since we're pushing most people to use CRDs, and that's where a lot of the community momentum is going to be, is since, at least for the short term, we're going to be using API aggregation, I want to make sure that is sort of a well-supported path. And if everybody else jumps off of it and we're the only people still using it, I worry that we're going to end up sort of becoming the de facto owners. And I really don't want to have to own the API server builder or running, like the sort of use case of running your own aggregated API server. So I just want to make sure that sort of remains a sort of first-class supported sort of deployment model, at least until CRDs have feature parity with aggregated APIs.
I think it will be. I think from my standpoint, your larger risk is that given the additional freedom that owning your own code gives you, you decide to like set off in your own direction, and your API deviates from the conventions that are possible with CRDs, and then we layer on additional structure in the project, and then you're left figuring out how to rebase on those new conventions. And the newer clients don't like to talk to you, and you can't take advantage of a lot of stuff in the future. That to me is a bigger risk. But if you're just using API server builder and doing Kubernetes-like things with your API, then I think you're safe. Does that make sense?
Yeah, and I think that's sort of the plan, is we're not trying to do anything necessarily off the beaten path. We're just trying to reuse the existing infrastructure in a way that's not quite possible yet with CRDs.
I think you're safe, and if you ever think you're doing something weird, I'm always happy to look at it and say, yeah, that looks safe, or yeah, that doesn't look safe.
And using API server builder gives us an assurance, right? Because that's the same type of people maintain the code. So
yeah, if Red Hat's talking about bringing the API extensions API to GA this year, which would be even a strong commitment of it being possible to use the extension API server mechanism. That's not quite what you're saying, though. You really want the API server libraries to continue to be able to be used to build your own binary. We don't have like a GA notion for that. I don't see that going away soon.
Eric, can I ask a controversial question, given that I believe you work primarily on CRDs?
Love those, yes.
So I want to say, first of all, that like I very much appreciate the work you are doing to make adding API objects easier, but why are we doing CRDs and not making the API machinery and API extensions easier, right? Could we not get most of those benefits by having, a super smooth builder, we talked about having the etcd, being able to inject into an existing etcd for the GKE scenario, that sort of thing?
So 2 reasons, I guess 3. One is, it's very, like, you've been in the community for a long time, Justin, so you understand a lot of the nuances of Kubernetes APIs, versioning, style, apply, all that stuff. It takes a long time to build that understanding. And so the way that we build people, keep people on that golden path is by giving them less choices, and CRDs gives them significantly less choices. We also want that path, so we want the Kubernetes API platform to be cohesive, and we want to tell people to start on the easiest path. You guys are pros, so I'm comfortable like that you're going to wander off and use the hard thing and not screw it up. But most people I would not be comfortable with. And then the third reason is that we want to be able to bring new features without you having to rebase. So for example, we're going to apply to the server side. We can't do that if you guys don't rebase to pick up those changes, or like chunked APIs. You'd have to rebase to pick that up. With CRDs, you'll just get chunking for those because you're just installing a declarative definition. So those are the 3 reasons why we like that path. But we realize you need an escape hatch, and I'm committed to there being some kind of escape hatch. There may be some rebase pain on that escape hatch, but it'll always be possible to do that.
That is good. Yeah, the one, I think that the big escape hatch problem for me is the lack of, that the format in etcd is different, right? Like the CRDs are wrapped, if I'm not mistaken.
When would that come up as, like, why would anyone ever see that?
Just because, so if I start on a CRD and then I change my mind and want to do API machinery later, right? It is harder to do that migration. It is a dump and restore type.
There's a trick you can do where you can install an aggregation. If you start on a CRD and you want to move to aggregation, you can install a facade that then goes back and talks both to its own storage and to the existing CRDs, and then manages the migration itself. I haven't figured out all the details, but there's no reason your aggregated API server can't go back and look at the old resources. You might have to bump the version or something like that, but I believe that there's some paths that are possible there. They're not simple, but that's the cost of being on the escape hatch.
That's a cool option. Cool. Thank you.
Yeah.
That kind of broaches a topic I was curious about. When and if CRDs become feature sufficient for what we need, and we just want to run the standard API server with all the other API groups turned off, is there any sort of definition of a transition plan from aggregated APIs, like as long as they don't violate certain things, but from aggregated APIs to CRDs?
The main thing you could do to not be able to transition would be to define your own sub-resources. We don't have a way, we're not sure we'll ever have arbitrary sub-resources for CRDs, or do weird things in the, storage layer, right? Or try to guarantee atomicity across, adding multi-object transactions because you can do it because you've modified the code. Those are things I can't help you with if you do that. I'm not sure that's answering your question.
My main question was, is there a plan or at least a high-level discussion happening about we want people to adopt CRDs, but the features aren't ready yet? Do we even have a plan or a simple one-pager to say, hey, when we get these features, here's how you move?
No. I'm trying to keep people on CR. I can't anticipate all the things that could go wrong that would prevent you from moving, so I can't write that doc, which is why I'm trying to discourage people unless they have a strong reason. And so most people are using CRDs, so I'm just mostly my effort is keeping them there. and understanding why people aren't there.
Okay, I was mainly looking for the optimistic documents. Like, if you've done nothing stupid, here's how you move.
Okay, I will. That's good feedback. I will try to see if I can sketch that out and share that. Any more questions?
The question is for the API server builder. Right now, the project still marks alpha. Is there any plan to for this tool to become at least beta in the 2018?
I know that the Phil Wittrock, who's one of the people on that, has a new thing called Kube Builder he's working on. He hasn't announced it yet. So I shouldn't have stolen his fire, but like he's actively working on the next generation of it. I don't know what his alpha or beta plan is.
Okay.
Reassuring to know that the guy working on it is still working on it.
Yeah. Yes. He's very helpful. Help out fix a couple issues already. So.
But I don't know. I can't say that there's a commitment to that indefinitely. But it's open source, so.
Yeah.
Well, that was my point before, is I don't want to become the owners of it just because it's open source, right? That's not the primary mission of our SIG, and it's not really our value add for the community. And so we really like for, maybe it's not just Phil, but for the API machinery SIG to sort of commit to owning that going forward.
You should go make friends with the Metrics API because they're committed to using it forever. So at least you can be half owners with them.
Well, what I'm hoping is that they own it long enough and give us a transition path off so that we can be on sort of the happy path with CRDs once CRDs are feature complete. Like Chris was saying, I don't think we're planning on doing anything that will prevent us from doing that. We just need features that don't exist there today, and we're not willing to.
I can't see it becoming hard, becoming burdensome for you, like significantly in like a year's time. And this project moves so fast, I'm not going to guess where other stuff is in more than a year. So, sorry.
Yeah, no, I think that's the best we can do.
All right. Thank you for inviting me and letting me talk and hear your thoughts.
Thanks for coming, Eric. I think this is really useful and helps sort of bridge our connection, at least starting to bridge our connection with the API machinery SIG, who we're going to have, like you said, have to become friends with here going forward to make sure that this stuff continues working as we expect it.
Yep, and I'm etune@google.com. If you guys have a modest number of follow-up questions, I'll try to field those or forward them. Don't abuse it. Thanks. And Robbie knows where to find me too.
Yeah.
So
thank you, Eric.
Yeah.
All right, Chris, you have the next agenda item: splitting up API groups.
I guess that's me. Yeah, I'm sorry I wasn't here last week, but there was someone suggested that we split up the API groups, and then I didn't know about that, and Rodrigo pointed me to an issue. I'm just not convinced that's a great idea because currently the machines depend on input from the cluster type, and splitting it out may turn into a versioning nightmare where like machines v1 beta 1 needs at least cluster v1 alpha 2 or something like that. And I was just wanting to maybe understand that. Happy to take the discussion to the issue if it was discussed ad nauseum last week.
So Martin, I think you brought that up last week. Do you want to follow up?
I mean, in the current machine implementation, the machine types, there is nothing binding the both together, more or less.
There's nothing in the type definition, but in the prototype controller and everything.
Yeah. In that, yes. But
yes.
But the machine functionally, it's kind of different. Let's say subgroup or step resource. Just if you put it in a semantic way, more or less. And this was my main concern, more or less.
It is a different type, yes, but it is closely related to the cluster, and I think you need there were basically some cluster level configurations that need to be known cluster wide that machine has to pull from.
Yeah.
Like the pod cider has to be known cluster wide, so you know, like if you're using kubeadm, it's the 10th offset of that pod cider for DNS for every node needs to know that.
Yeah, I also feel like it's a closely related thing. maybe for the deployment, the machine deployment or machine set could be separate namespace. We can discuss that. But for the machine and the class, I feel like they should be in the same group.
I agree that it is confusing that there's no explicit relation there, but we were just operating under the condition that there would be one cluster object per namespace, and it would be tied to all the machines defined in that same namespace. I am definitely willing to entertain more explicit connections in that API, but I don't think they should be in separate API groups. Again, if everyone feels I am wrong, I'm willing to back down from that, but
Yeah, it's okay.
So Chris, you mentioned that there should only be one cluster per namespace. What would it look like if you created more clusters in the same namespace?
hopefully it'll look like a validation error once we put that in.
Okay, so that's what I was wondering, is that something that we want to enforce?
We either enforce that or we come up with a better way to associate machines to cluster, maybe a more explicit way.
In our project, we currently have like the notion more or less of a project, which is more or less a namespace, and inside of this project, inside of this namespace, you can have multiple clusters. So at least from the way we actually do our deployment, so of Kubernetes clusters, we really want to keep it like this notion.
So you want to allow multiple clusters per namespace?
Oh yeah, definitely.
Okay.
We had a similar situation where we were considering namespaces as potentially one account, like a customer account, which could potentially, it would normally be one cluster, but it could potentially be multiple.
All right. Do one or both of you want to propose a GitHub issue to hash out how we should solve this? Because it sounds like we need to go with a more explicit association between machines and clusters.
Sure, I could do that.
Yeah, great.
Yeah, I think that makes sense. I think we were trying to keep them very loosely coupled, but it sounds like they're not sort of semantically loosely coupled anyway, and so making the connection explicit makes a lot of sense, because then you can easily tie them together, and it gives you the flexibility to have more than one, which right now you could, it just doesn't make sense. And if you tie them together explicitly, then you can have more than one, and it actually does make sense. And it sounds like there's some valid use cases for that too. So I think in that case, we should probably close the issue that's linked to here, that was added to the alpha milestone, and replace it with an issue to explicitly tie the resources together and mark that for the alpha milestone. So I think, Devin, you'd volunteer to create the new issue.
Yes.
And once you do, if you could ping it to either Rodrigo or myself, if you don't have permission to add to milestones, we will do that.
Okay, sure.
All right. Anything else there, Chris?
No, that was my only discussion point. Thanks for hearing me out.
Thanks. All right. So next, there was an issue that was extracted from the initial machines PR about changing the type of provider config. I just wanted to mention this briefly and ask if there were any objections. I think so far I've only seen people saying yes, both on the initial PR and on this issue. But I wanted to put that in front of folks to make sure nobody was saying no before we just went ahead and did that. I'll give people a couple minutes to read through it if they need to.
Just one thing for the internal version, if you're going to support and if you're going to keep the aggregated API server, we need to have this type needs to be I think object. Yeah. So this is another thing that we have to consider as well. And I'm not sure that the client automatically, because raw extensions is like a struct, and inside of it there's like the raw data, and there's also like an optional object field, and I'm not sure that the client Even the automatically generated ones populates this object, so we have to do some magic with the decoders.
Okay, yeah, so the issue suggested either runtime.object or runtime.raw extension, and it sounds like you are leaning towards runtime.object as being.
I mean, no. For the external versions that are with with V1 alpha, it should be. I mean, according to the to documentation, it should be raw extension, and for the internal version, it should be object on the object. I think I haven't tested it yet.
In Service Catalog, we use raw extension both in the internal and external versions.
Yeah, but if I remember correctly, you only put some JSON blob there, not any structured type, like type resource, more or less.
I'm curious, if it turns into a runtime.object, does that mean that object has to be registered with the API server for the internal version?
Yeah. I mean, internal versions are only for the API server, more or less, because there's nothing to do the conversion. And I don't think that the external version, I mean, by default, the converter, the decoder will actually, I think, complain that it cannot decode to object, to an interface, more or less.
Yeah, I'm a little concerned with having to register all the provider config types with the generic API server. I'm not against it. I just need to be convinced that that's not going to be an issue. Like if I'm just deploying, say, to an AWS cluster, I don't want to have the Azure types, the GCE types, and all the other types I want registered with that API server. If it can be done dynamically instead of compiled in, then maybe that's fine.
Well, you can more or less. Well, we can have more or less the control, the API groups that you can register, I think, or select which API groups you want to run on your API server, so you can have something.
But for those flags to work, they still have to be built in, and I was hoping to go for a deployment where the aggregated API server is generic, and the only provider-specific part was the machine controller. Again, I'm not against it. It just sounds like there needs to be some more investigation. I think we should keep that issue open, continue investigating it. I'll comment on that issue with my concern.
Thanks, Chris. So it sounds like we are not quite decided on exactly the right path forward here. We might need to do a little investigation to get enough information to make the appropriate decision. This is another case where I worry that we could back ourselves into a corner and not be able to switch to CRDs if we are doing something custom with the API server. If we're just registering objects, it's probably okay. If we're passing extra flags, that seems a little bit less flexible, because I don't want to have to restart the API server if I want to manage a different, basically install a different machine controller into the cluster. That shouldn't require restarting the API server.
Do they actually have to be real API types that are actually registered anywhere? What are the rules about this?
I think that's what Chris was asking with runtime.objects is does a runtime.object have to be a fully fledged type that the API server knows about, in which case you'd have to register it.
My understanding is they do not, right? It's only if we do something that, but you're saying if it was a CRD, might it then have to be a real runtime object or a real API type?
Right.
Yeah, I only have limited experience on this, but I feel like the aggregation is done by claim a resource path to the main API server. The main API server not necessarily know all the detail about this object. It just forward all the requests from through the aggregator from the main API server to the extension. So
Okay, so I think Chris has an action item to update the issue.
Again, it's not an objection. It's just questions I had that need to be answered.
Excellent. All right, if there's nothing else there, we'll move on. I was going through the API definitions last night and came across a number of things that I wanted to bring up during the call today. Some of these hopefully will be somewhat quick, hopefully most of them, if not all of them. So the first one was terminal versus transient errors. So looking at the Machines API, the documentation basically says that we have, we decided not to use conditions because Eric Toon and Brian Grant suggested that conditions were on their way out and we shouldn't be using them for anything new. And the new way you're supposed to be doing things is sort of putting top level errors, like rolling errors up into the top level of your status objects. And so we have two error fields. We have error reason and error message. And the documentation says they should not be set for sort of transient errors that you're expected to fail from, and they should only be set for terminal errors, which is a case that you're expected to never get out of. And then if you look at the documentation for the actual reasons that there could be errors, many of them say this is a transient error, which seems contradictory with the documentation of what they're supposed to be setting, which is a terminal error that is not actually transient. So it wasn't clear to me, and maybe nobody on the call knows, since I think Jacob wrote many of these docs initially, whether the documentation is just inconsistent, but the principles are correct. Where when we say that they're transient, what we mean there is that they are only recoverable by a person and not by automation. Or if we have sort of a mismatch there. In addition, in the proposed machine state diagram, which we've talked about a couple of times on this call, we purposely did not put any sort of terminal error state. And that's something we learned from GKE, where we do have a terminal error state in our internal state diagram for clusters. And we found that can be kind of a painful situation to be in, because when you have a terminal error state, it means that you go there and there's really no way out. And in a lot of the cases, like if you look at the different types of errors, they are actually potentially recoverable, right? So like a crate machine error, the example is timeout connecting to GCE, which to me sounds like if you tried again, maybe the service was down and GCE would come back up and you'd actually would be able to create a machine at some point in the future. If it's an error that you're out of quota, right? So insufficient resources, you can actually fix that out of band by adding more quota to your project, and then have sufficient resources where a machine controller that is constantly trying to reconcile state would actually be able to get you out of this error state and back into a state where you're working. So I guess what I'm trying to get at is it's not clear to me if we don't have conditions, which conditions seem to sort of represent states and a state machine, whether how we want to use these error fields, right? What information do we want these error fields to convey back to clients of the Machines API? So I'm gonna stop talking and let somebody else jump in here.
I can hear Rodrigo because he's right next to me, but
Yeah, nobody else can. maybe his microphone is not working.
Clarifying question in the interim. We do expose the state as a field, correct?
We don't. So that was another thing that I had on my list of things to talk about was, or maybe I forgot to write it down. Should we expose like the explicit state machines? Daniel Smith's feedback in the document that I've linked to is that we decided not to do that with some of the other Kubernetes types because they thought that once those states were exposed and the transitions between those states were exposed, that trying to change the flow between states would constitute a breaking API change. I know that if you look at some of the other sort of machine management tools, like the ones that the SAP guys have, it's got sort of two fields that represent state. You've got one field that represents sort of the steady states and another field that represents sort of most recent transition. I don't know if you guys have tried to change what those states look like and found that it's caused any sort of compatibility problems with clients or not.
It's still alpha, so we probably change those things, but yeah, we are planning to getting rid of those, and yeah.
I would point out that notably pods do expose a state, right? And that is useful for the machines, for the machinery that builds on pods, like replica sets and deployments, which have obvious analogs to what we're doing.
So, I mean, we have a sort of implicit notion of a node being ready, right? So you have a machine that causes a node to be created, and that node goes into a ready state. And if you look at the machine set API that went in, kind of like replica set, it's got fields for number of ready pods and number of available pods, which is slightly different. Right, so we can sort of take that implicit state from a kubelet reporting status and saying that the node is ready as a state for the machine. But in the machine state diagram, that is one of the potential states, which is, well, actually that represents more than one potential state, right? Because if a node is saying it's ready, it could be in the serving state, it could be in the drained state, right? The kubelet will still report ready if it's in the drained state. You can sort of infer that because it'll tell you that it's been cordoned. But doesn't actually tell you if it's been drained or not, just tells you if it's been cordoned. It's not schedulable. And so I think we have a potential to actually have sort of a more refined state machine that we could expose, and we'd have to make sure we reconciled that with like the actual state on the node. But yeah, right now it's not explicitly exposed. It's sort of implicitly exposed.
I don't want to dominate, but one way to solve this would be to drive it by the use case of the machine set. Say, what exactly does machine set need? And that is what we should make sure we build into machine. And then maybe we find that error text or whatever is not even used. So it's purely informational.
Yeah, I mean, it was put there because we needed a place to surface errors initially, right? So if you say create machine and you try to create a machine that like just is completely invalid, some of those you can catch during input validation stages, and some you can't, right? You go out to the cloud provider and it says, sorry, this doesn't work. And that was sort of a way to surface that back to the user. So you'd say like, we aren't gonna bother trying again. But I think some of the error types that crept in there are things where we should be trying again, right? Like if you're out of resources, that could be a transient state. If there's a stock out, that sounds like a transient state to me. Like those things should get resolved or could get resolved. And you need to bubble up the fact that it's not working right now somewhere, right? And I think that's what conditions were used for.
We do have events, right? Which is pods might have the bad image or can't have credentials to pull the image, and that it comes up as an event, and I don't remember what the status is during that.
Yeah, that's the documentation says we'll produce events, but events are not really reliable for higher level controllers to be built on top of, right? Events are more transient. They don't have sort of the same guaranteed storage as your current status field does. It's easy to miss events, right?
Yeah, I mean, I guess the point is that the replica set doesn't do anything with the idea that a pod's image can't be pulled, right? It won't behave any differently, and so the information is only of value currently to humans who are looking at the events and maybe an aggregated system in the future. But I guess the question is, could a replica set do something smarter with that information? But more pertinently, could our machine set do something smarter with that information?
Yeah, that's a good question.
Can you hear me now? Okay. So the discussion about conditions, I added the link to the meeting notes as well, with some history on conditions and why we're not using those. So the thought process after reading quite a bit yesterday is that like we would be using kind of events for anything that is transient to the controller. So if the controller is retrying, then I just want to output something about what it's actually doing, failures that are happening. It would be events or kind of a logs, controller logs. We didn't decide or didn't discuss what's the line between the two, but essentially that's kind of if the controller is retrying, it emits logs in our events. At the moment when the controller gives up, it bubbles up this information in the error field. And that's kind of that's I think what's being called terminal, but terminal may not be a kind of a good term, right? As you said, coda, you might try a number of times and eventually you give up, and then you will output coda back to the user, right? Although you're gonna if you try again later, you might be able to fix that. The same goes for any internal errors, internal cloud stockouts or something that might not be expected, not be caught in validation errors, and later they happen. Eventually the controller gives up, and that's kind of what gets bubbled up. That was sort of the thought process in the machine set, and we can revisit it, make consistent across everything if needed. That was about it.
Should it give up though, or should it just back off and retry at a low frequency? Right. I think both those cases you mentioned, we shouldn't give up and say we're never going to try to create this machine that's part of machine set again. And maybe the difference is on machines, we say we try to create this machine, we gave up, and then that allows the machine set to try again later, and it can do the back off. And I think that was Justin's point, is what fields do we need for our automation to work? So I think there are two things. One is how do we get error messages out to users so that they can manually fix things if necessary? Like if there's a quota problem, in the same way that if you try to pull an image on a pod that doesn't exist, your replica set won't scale up, and you can look at it and figure out why and fix it. And so we need a place to bubble up the things that people might need to go fix out of band, and then we need to have enough fields there to build higher level tools. So maybe the fields there are sufficient for both of those, and we just need to update the documentation to make it less confusing. But what I found reading through it was it sounded sort of self-contradictory. So maybe the answer is we sort of keep building the machine sets, start looking at machine deployments, and figure out if the fields are correct, and if so, let's just make sure the documentation is clean.
Yeah, I think Justin's point is really good. Let's kind of go over the use cases and where this information needs to be bubble up for automation, and then adjust as needed. So I think that makes sense.
Cool. So next thing, we have the container runtime in the machine spec. It's got used in a field that is also in the machine status. So we probably just don't want to change it because it is, I think, useful to have in the machine status. But in some recent discussions I've had with folks from SIG Node, it sounds like the future direction for container runtimes is that they are going to be tightly coupled and bundled with the underlying operating system. So for example, if you're running RHEL, you might get CRYO as your container runtime. And if you're running Ubuntu, you might get Docker. And if you're running CoreOS, maybe you get Rocket. But the intention wouldn't be to go and install Docker on CoreOS. It would be, we get CoreOS, it has Rocket that's been validated as sort of a functional pair of OS plus container runtime. All the container runtimes implement the CRI interface. And so the kubelet doesn't really care too much what's running underneath it as long as it passes the node spec validation. Right now we have in our declarative API a way to specify, I want this container runtime with this kubelet. And it's starting to sound, if we kind of read the tea leaves, that future maybe doesn't make sense. And instead we should be saying, I want this version of the kubelet. And when I get an OS from my environment, that will come with a container runtime. That should be okay. So I was kind of hoping to just go in and rip out the notion of a declarative container runtime, but it gets a little bit muddled because it's in the machine status as well. So one option is to just update the documentation to make that explicit and say, don't set this field, and we can reject it. That way we can leave it in the status object. Another would be to break up the two types, so we have a different type for spec and for status.
How pervasive, are images with the runtime, baked into them? If you go to any cloud provider, or if I have on-premises and anyone start using an image, Do we have the majority of images with the container runtime today? Don't know if I were to pick one, a random one. I would guess no. So that's kind of where I'm going with this question. But
I mean, I can answer from my experience on AWS, which has a pretty broad range. Most of the stock images, Debian, Ubuntu, Rails, CentOS, do not include a runtime at all. Some of the ones which are like kops and Kubernetes, I guess, builds one specifically which bakes in the relevant version of Docker, but that is something we do, and it's purely an optimization to speed up boot. Most of them do not have Docker built in. The complexity is that, like, I think the reason is that Docker versioning doesn't match up with the Docker speed of version doesn't match up with the lifespan of OS releases very well. So it is a pain for people to bundle it. I think there are exceptions. Like I think Red Hat has a Atomic, right? I'm sure their image does, and CoreOS includes Docker because you can't install software on CoreOS basically, or whatever they're shipping these days. I don't know, but yeah. In general, the answer is no, though. It is not included.
Yeah, so I think that's true. The state of the world today is if you ask for just an OS from Amazon, you're not going to get one that has a container runtime. And so maybe you have to install one. And maybe for something like CI, it's important to be able to specify a version. I guess what I'm saying is that looking forward, I think what we're going to see as we see projects like Boardroom from Heptio get spun up, as we look at people building more things like Atomic or CoreOS that are more sort of container optimized operating systems, is that we'll start to see a tight coupling. And if you say, give me an Atomic image and install Rocket on it, it's just not going to make any sense, because Atomic's going to come bundled with a version of Docker, and that version of Docker is going to work.
Hey, Rob, I have a suggestion, maybe. Could we just add an enumeration to the existing fields for not only the container runtime version, but also say like the kubelet version, to just have an enum that specifies that it's OS provided? So that way that there's an escape hatch to not use that feature.
Oh, that's interesting. So I think there is a provision in at least one of those fields now. I mean, you can leave them all blank and you basically just get the defaults, right? And so maybe we say, by convention, we expect most people to leave these things blank and just take the defaults. But there are some escape hatches where you might want to specify a specific version, and some machine controllers will just reject, some or all of those requests if it's not supported.
Yeah, I think you'd leave it to the machine controller to do what they do with that field, right? So that's something that could be relatively opinionated for the use case.
And another thing, right now the node has like a node info, if I remember correctly, and there is like the container runtime version as well. So I'm not sure why we should keep it in a status, more or less.
Yeah, so the comment for that field basically says we are copying it over from the node because that puts it in the same structure and format in the spec and status, which makes it really easy for controllers. And the field names are all different in the node object. So if you follow the reference, from an end user's point of view that's trying to like introspect machines and nodes, it makes it difficult because the fields are inconsistently named. And that basically puts the burden on the controller to do the mapping from, I understand what's reported in the node object, and I'll map that over to the machine object to make it easier for consumers of the machine API. And that's another decision we could say, let's change the burden and put it on the user because the information is already surfaced in the API elsewhere, and people should just follow the reference. And that would also potentially fix the problem because then I could just rip it out.
So say we were not to support this field, is this something we would just expect in the provider spec? In the case that you would actually need it?
Yeah, so like if like Justin was saying, if you're on Amazon and you say, give me a stock Ubuntu and I want this version of Docker installed, you could put that in the provider spec, or that the machine controller could just pick the right version based on the OS, right? You could encode that logic of how to choose a container runtime in a couple of different places. But the provider spec would be one place you could put it.
Yeah, I think my concern is just for a new user, to the API, if this is something that is like I'm bringing my own image, or I have this image I've been using and now I need to kind of create a new image and bake the Docker version or any other software to start using the custom API, that's one extra step for them. And that's just another consideration, right? If the majority of the users, could, do that or would need to do that, then that's something to consider. I think we're converging that, like, at least supporting an image that comes with the runtime would be, we certainly want to do that and have it probably some sort of a node spec that we're going to validate against, make sure the runtime is in place, etc. when we're deploying. I think we're not sure if we're going to keep the installation code, that installs on the images with all that, right?
I'm just curious, outside of CI scenarios, is the container runtime a meaningful choice?
Yeah, I think that's the other thing I was kind of getting at here is, for most people, they say, give me a machine with this version of the kubelet. And because we are abstracting out the container runtime through the CRI interface, and because it looks like we're moving towards having it tightly coupled with the OS, like, that's something that users probably shouldn't care about.
But some users care about with custom CRIs, for example, like kata containers.
That is a good point.
Yeah, I mean, I would care about what version of Docker I'm running. It's often not new enough to support features like multi-stage builds.
That is the huge one we see on COPS, which is everyone wants a version of Docker that is still supported, for example, by the Docker project, and like Kubernetes versions do not intersect that set. But I think we could solve that the right way.
What's the right way?
Fork Docker.
Well, I mean, we're getting containerd at some point, right? Which is the runtime part of Docker, and maybe it's support lifespan and versioning trajectory will change, right? Chris also points out in chat that users probably don't care, but ops folks probably do care about specified. And to be clear, the users I'm talking about are the ops folks, right? The primary users of the cluster API are the ops. They're not the application developers. And so if we think that the ops folks do care, then maybe it is worth leaving in.
Yeah, I mean, if the machine controller gives me a way to define what CRI is running, that can make it really easy to do a rolling upgrade or a rolling rollback, to respond to an unnoticed bug or something that affects an environment in a quick manner.
Just a question. I'm sorry, this is a little bit foundational, but I'm not aware of whether we're targeting sort of a in-place upgrades or blue-green, because that would start to play into the inability to update your container runtime.
I think we're trying to leave the API flexible enough to do both, and letting machine controllers decide if they want to try and implement both.
Okay.
So certainly blue-green is easy because you can always create new machines, delete old machines. You can sort of orchestrate that at a higher level, and in-place is more difficult. And I think most people have not implemented in-place upgrades for Kubernetes today, but I don't want to close the door to doing that in the future. I think there's some valid use cases where we'd want to do that.
Okay, thanks.
All right, I had a couple other things to discuss, but it looks like we're just about out of time. So I'm going to punt those to next week. And thank everyone for coming. And we will see you all again soon. A couple people had action items to go and open issues. Please make sure you follow up on those. And certainly if people want to keep chatting, we've got Slack, and email and so forth. So thank you everyone for coming, and we'll see you again soon.